I'm Pedro Lacerda, and I was born in Portugal, but now I live in Northern Ireland, part of the United Kingdom, in Belfast. I work at Queen's University Belfast. I study small bodies of the solar system. So the solar system has planets, big things, about 8, but the solar system has a lot of other stuff, smaller things, comets, asteroids, icy moons, and other things, and I study those because there's a lot of them. And I think we can learn more from them because the planets are very weird. They're clearly outliers. They're clearly different from the rest because they just evolved in a strange way because they're too big. So they evolved out of control. But the small objects, there's a lot of them, and they're more uniform, although there's slight differences that we try to understand. And that's what I do. I just study those small things, like little fossils of the formation of the solar system that are spread throughout the solar system. An easy example to explain is this big object that orbits the sun beyond Neptune. It's about 2/3 of the size of the moon. So if you'd see it in the sky, it would be, a third of the moon roughly in width. But that object is called Haumea. Spins very fast, so it spins once every 4 hours. So it spins 6 times faster than the Earth. And because it spins so fast, it's elongated into an egg-shaped thing. And so while it spins, the cross-section changes from a big cross-section to a small cross-section to a big cross-section, so on. So it reflects a proportional amount of light. So you see a light curve when you observe it. You see the light coming from this object to vary in a periodic way. And I did observations of that object that had been discovered before. People had measured the rotation before, but they had done it on small telescopes, so the measurement was not very good. It had a bit of uncertainty. And I thought, this object is big, it's very bright, so I'll do it again. And I did it in a lot of detail, and then you could see that the light curve, was not symmetric. So this object, there was something about it, that it wasn't just a perfectly uniform egg-shaped thing. It must have something on the surface that makes the light curve asymmetric. And the first thing I thought is maybe there's sort of a spot on this object that makes one part of it a bit darker. And so that's when I came up with this model. That's an example of something that I thought, model, maybe there's a spot. And so I generated a model of the spot, and I changed the size of the spot and the darkness of the spot and so on, and I found the best fit to the light curve. Then I published a paper on it, or 2 or 3 actually, and that was a nice thing, because you just got data that surprised you in a way, come up with an explanation, you fit it, and then since we've never seen this object up close, in the future, a few tens of years in the future, people may go up close and see if the spot's there or not, so that's a nice thing. I think it's important statistically because there's a lot of them and because they're everywhere. So they're very nice tracers of, it's like you have a system that evolves in a way that you don't understand very well. And if you could sprinkle it with a lot of particles, you throw a lot of particles in, you see them moving around, and you see them change, their colors change. And so you could follow these changes. If you were there, you could follow these changes and understand what is happening to them. We don't have that advantage. We all look at them now, but we look at those particles, lots of objects, and we try to look at their properties and understand what happened to them in the past. But the advantage of the small objects is that there's a lot of them. And so, as I said before, the planets are only 8, and they're strange. So if you just study the planets, you don't have a good statistical coverage of what you're trying to understand. So the small objects are just a lot of them. So I think that's a nice thing. You can always study another one, and then another one, and another one, so you can learn more.